Hello and welcome to Book Bites, a book club podcast for developers. We're continuing the Imposter's Handbook, a CS primer for self-taught programmers by Rob Connery, and this week we're going over chapters 12 and 13, which is functional programming and databases. I'm Adam Garrett Harris.
I'm Safia Abdallah.
I'm Jason Staten.
And Jen this week is very sick, so as she says, too sick to knit, so she can't be on the show today, but we'll carry on without her. All right, so I was pretty excited about the functional programming chapter. What about y'all?
That's definitely where I spent the majority of my time between these two chapters.
I found the databases chapter a little bit more intriguing, but I definitely did like the way that the functional programming chapter was set up, like the 4 themes that Rob separated it out into.
The 4 themes, what was that?
Yeah, so if you're reading along with us, the 4 themes are described on page 291. They are the theme of immutability, purity, ideas around side effects, and then ideas around currying. And the book kind of went into each of these topics a little bit further in that chapter.
Nice. Yeah, and it says based on Lambda calculus, which we talked about before, but honestly, the only idea I think that for me carried over from Lambda calculus is kind of everything can be a function and you can pass around functions and use functions a lot.
Yes, the functions as values, rule of thumb.
Yeah.
So in asking about the background that both of you have you done much in the line of functional programming, or tell me about that experience that you've both had?
Yeah, so I can talk a little bit about it. In university, we were working with a language called Racket/Scheme, which was designed to be a functional programming language with a Lisp-like syntax.
Mm-hmm.
So I did that in a couple of classes in college. And then in my day-to-day work right now, I am using a programming language called Elm. In parts of our code base, it's a functional programming language that compiles down to JavaScript. And that's pretty much the extent of my experience with functional programming languages.
Oh, that's super cool that you're using Elm.
Yeah, I was going to say, yeah, it's interesting. It was my first time using that language, and especially in like a application or like a software that people use on a day-to-day basis, like, you know, like not just like a pet project or something like that. So yeah, it's been interesting learning it and figuring it all out and stuff. It's definitely like a mind shift.
Yeah.
Mm-hmm.
Yeah, it's so weird. It doesn't let you do any side effects at all, but side effects still have to happen, but they're all taken care of by the Elm runtime.
Yeah, and for me personally, the syntax was one of the hardest things to grasp, and also just its strictness around typing. Elm has a lot of type inference built in that's designed to kind of avoid errors that might come up in runtime. So, you know, you have strict types defined for something that are going to capture all of like the annoying corner cases and like flukes that you get when you might be running a program and give you a chance to deal with those. So navigating its strict typeness and like building a good type model for the application was something I had to figure out too. Because it was like you have to be like very strict and precise about types and make sure that it all worked well in the Elm model. I don't know if I'm explaining this well.
Yeah.
Yeah, that's it's actually one thing that I don't feel like was brought up a lot within the book, at least as far as I've seen, and I don't know if there's a chapter on it. Maybe season 2 is talking about static typing versus dynamic typing, right?
Yeah.
And then there's also like strong versus weak typing, which is a different thing as well. But yeah, coming from being in a JavaScript space where like everything's dynamic and a little bit more free for all versus like an Elm where you have to type things up front,
Mm-hmm.
your mental concepts and approach to handling problems is definitely different. But that's awesome that you're using Elm. It's something that I've only tinkered with on the side. So like to hear the experience of somebody using it in production, like I'm curious how you're perceiving that within Elm as we kind of hit through some of the topics.
Yeah, I would say it's generally has been pretty easy for me to grasp and start to work with. The one way that Elm is lacking with respect to JavaScript is just around developer tools. So it's kind of hard to get a good debugger set up in Elm, and when you're like trying to work through things and like step through everything, there have been a few contexts in my day-to-day job where I was trying to debug an issue, and I was like, oh, if I could just put a breakpoint here in this Elm code, that would be so great. But it's not set up for that at all, so that makes it difficult. I think the general recommendation for debugging is you use their like debug.log statement, which is just like console.log.
I thought the promise was that if it compiles in Elm, it just works.
Oh, I have fun stories about that. There have been a few occasions where, so the part of the code base that's written in Elm is not the entire code base. It's sort of like a small chunk of it, and it sits at the intersection between two other code bases that are not written in Elm and that are not as strictly typed. So there are situations where Elm is communicating with an external system, and that external system unexpectedly gives it data that causes Elm to bork. So it's not within Elm itself, it's within its interfaces to other parts of the code base. I don't know if that made sense.
Yeah, my understanding was that when you're getting data from the outside, you have to take care of every possibility and handle every case.
Yeah, you have to write decoders to decode the data that comes in, and then encoders to send it back out. And those are where a ton of the bugs happen.
Gotcha. Okay, so as far as my experience goes with functional programming, about 6 years ago, I tried to take a course on Scala on Coursera.
I think they're starting that up again.
Oh, yeah. And it was taught by the creator of Scala. And it was just way over my head at the time, but I thought it was really cool. And then a few years ago, I read some of this book called Professor Frisby's Mostly Adequate Guide to Functional Programming, and it uses JavaScript. I don't know if you've seen it or not, but it's free on GitHub, and it's really cool. And then at my last client, I did use a little bit of Elm.
Oh, wow.
Yeah, so I've written some functional programming in production. It was just same kind of thing as you, Safia. It was just a tiny little part of, this was a really tiny part of a website, but It was fun.
I know Elm recently released their 0.19 version, which is like a long-awaited update. And I was exploring some of the things they'd laid out. And they do have an example code base up that is a full-on web app written entirely in Elm. And I will try and find the link for it and put it in the show notes for people who are curious as to what a web application that is written entirely in Elm would look like, and not just as like a tiny auxiliary thing.
Yeah, I think it looks really beautiful, and they've got the built-in formatter, and the way everything lines up is really cool.
Yeah, when it works with you and when it's not super stressful, it is really great. And I guess that's just software in general and programming. When it like you get it and your mind is flowing and you're like in tune with everything, it works well. But yeah, when you're trying to figure out how to write a decoder to cover all the cases or something, that's not super fun.
Yeah. What about you, Jason? What's your background?
So I have less production functional experience than both of you, and so I have a little bit of Elm envy, I guess. But I have spent a good chunk of time doing some Clojure work in the past. I studied the programming Clojure book and then followed it up later with The Joy of Clojure, which was probably one of my favorite programming books that I've read, just because it really showcased how thought out the language was and how much it built on pre-existing concepts. Everything that they were going through in the book, where they talked, say, about software transactional memory, they went and said, well, here's the white paper for the thing, and it was written back in the 70s or something like that. And so like it's not necessarily these new ideas, but they show like how Clojure took these old concepts and applied them to a modern Lisp. And so I've spent time with that. I've also run a book club within a company doing Haskell work. And so worked through the Haskell Book by Chris Allen, and that was really enlightening. Haskell being on the other end, whereas like Clojure is dynamically typed. Haskell has an uber powerful type system that is a change to wrap your mind around. And so I definitely haven't used it within production, but a lot of the concepts do get applied within my daily work because, as you said, I mean, even JavaScript can have functional concepts brought to it with the way that, I mean, functions are pretty first class within it. I mean, we don't necessarily get all of these things, and they're not as baked into the language in the same way. Like it talking, I guess, bringing it back to immutability is something JavaScript doesn't have built in it by default, is persistent data structures, where if you were to go and say create a map or I guess an object in JavaScript, you can go and you can mutate that. Like you can go and add a new property or reassign a property within JavaScript, and it lets you do that. But if you were to use an immutable data structure, the way that you would actually approach it is to create a new object with that updated key, whether it be new or replacing an existing one. And in JavaScript, you can do that. It's definitely common now with the object spread operator, where you can do ... and take the original source and copy it. But in functional languages, one thing they have within them is persistent structures that when you say go and update a map or something, it doesn't actually copy everything, but instead it creates a new map with your single, say, updated key, and then everything points back at the original piece of memory as well, because you know that because that original piece of memory is also immutable, that it's never going to change. And so you don't have to copy everything. You just go and have a change set that points back to the original version of it. And so it's still efficient on that front.
Yeah. So in JavaScript, it just takes a lot more self-discipline to keep things immutable.
Yeah.
And yeah, it's definitely a common pattern to see now. Today, I actually found out that Internet Explorer does not support object.assign, which is kind of the old school way of doing an object spread.
What version of IE? Is it just prior to Edge?
Looks like all of them. Yeah, prior to Edge. So all the way up to IE 11.
Good thing for polyfills, I guess.
Yeah.
You talking about the discipline and immutability requiring developer discipline within a language that's not necessarily functional. And that's definitely one of the things that I like about when you have a code base that's written in a functional style or working within a functional language, is that the language, it provides you guarantees and lets you work safely without having to always concern yourself, is this thing going to get mutated from underneath of me? And instead, just write it in, like, if you're writing it within the bounds of what the language gives you, then you're going to be safe, versus like within JavaScript, I guess kind of going back to the Redux example or React for that matter, if your state is mutated, there's no safeguards in place that actually stop you from doing that. You can do that, and then your application can kind of continue to work or silently start acting weird. And it's all based on developer discipline, versus like having those things baked in can make your life a little bit easier.
Yeah, for sure. And it can seem annoying too that you have to try to make the compiler happy. And a lot of times we tend to think like, oh, the compiler is complaining or yelling at me. But it's forcing you to do something you should be doing anyway.
Yeah, I've had a lot of that experience with the Rust programming language. I just got back from RustConf a couple of weeks ago, going to Portland for it. And that was one of the major points that was brought up, is the compiler yells a lot, but it's often because you're used to doing something in a language that wasn't truly safe to do. And just think about like passing an object to another function within JavaScript. That object can go and get modified by that function before it's returned back to you. And you hope that it doesn't sometimes, but maybe it will, maybe it won't. There's no certainty on that front. And whether you have immutable structures, like you know that can't happen to you anyways, or in Rust case, calling function actually says, I'm going to mutate this thing, or I'm not going to mutate this thing. So like it's within the type system that it tells you that information. But things that you can be really loose on in some other languages, a powerful compiler can actually call those out and make it so you are not having to keep that in the back of your mind as a developer, but instead the computer is doing that work for you.
Yeah, that's a good way to think about it. It's doing that work for you. Yeah. All right, so that pretty much covers immutability, I guess. What about purity?
So I think It's coupled this way in the book, and I think it also makes sense for me personally, at least, to think about them together. Purity and side effects as things that go hand in hand. So purity is the notion that your function only relies on the data that it's given. So it's not accessing any like global data or things like that. The parameters that you pass to your function are all the parameters it needs to do its work. And then side effects are functions, the fact that the function will only operate on the parameters that you give it. So it's not going to mutate some global object or some other data element that you didn't give it. I try and do this in general because I think it makes code a little bit easier to test. And this kind of relates to the discussion that we've had in the last episode, is that when you write code with the intention, when you write tests first, or when you write code with the intention of testing it very well, you end up writing functions that are pure and don't have side effects because those are the functions that are easier to test. So that's one of the reasons that I employ that technique. Not really related to functional programming at all, just related to how easy it is and how safe I feel using that function and testing it.
Yeah, definitely. I think if you follow test-driven development, you're more likely to do this because it's easier to test pure functions.
Yeah.
Purity is one of the concepts that I wish that he would have put actually even before immutability. Because, I mean, like immutability is important, but I think having a function that works more like the mathematical concept of a function where given an input, you always get the same output out of it, like that being a pure function, that's what you get in math. Like you don't ever have to worry about some other thing changing your function f that you've written in math. And that was probably the most eye-opening concept for me when learning about functional languages long ago, that all of your state is just things that are passed in to your function. It's very explicit and obvious where that's coming from, versus even in an object-oriented language, like I had the example once of a person object, and maybe you had a method on that person of is old enough to drink or something, and that function itself or method on that person would be entirely dependent on the person's age, which is probably not something you would pass into the method itself, but instead you would read off of that object. And so the scope of code that you have to concern yourself with becomes a greater amount, versus if everything is just within that single block, it can make it easier to test as well as read. And I know like saying code is easier to reason about, that is a dangerous term to say, but in short, like sometimes it can be because your context you have to be aware of is smaller.
So why do you say it's a dangerous thing to say? I agree that it's become kind of cliche.
I guess maybe not dangerous, but cliche. It's also very opinionated too, in terms of what's easier to read.
It's subjective.
Yeah, like functional programming can be written in super terse ways as well. Like if you go and look up point-free programming, that is a realm of like making super terse code that is all just data transforms. And in one person's mind, that can be super readable and they know that data is just flowing through all their transforms. But somebody else would see it as totally unapproachable because they don't even have a way to inspect in between what's going on in the functions. So that's more of what I mean about being dangerous. So maybe it's just a subjective type of view.
Yeah, I guess it could really make people feel excluded if they look at it and it doesn't seem easier to reason about to them because they don't have the same context and experience.
Yeah, and that is something that I do try and keep in mind when working on a code base, is some functional concepts are fun to bring in, but if it's not really the norm for your language, you may be excluding others in terms of like making them want to work on that code base. In JavaScript in particular, there is a utility that's similar to Lodash called Rambda, if you've heard of it.
Yeah.
And Rambda is awesome because you can do all of these really cool functional things with it. Like it's got currying built in, which we'll cover in just a moment, and other niceties. But it also is a way to make a code base that somebody who's unfamiliar with it can take a while to actually go and grok. So you also have to consider, like, if you're working in a non-functional language and you're writing things in an attempt to be super functional, then you may make your code base unreadable by anyone but you.
Yeah, good point. Okay, yeah, so what is currying?
I went and did some Googling too, because he talks about currying, and then a little bit later into the chapter, Rob actually mentions partial application, and I was not totally clear on the differences between the two of them, and now I think I have an understanding.
Oh yeah, I see on the Wikipedia page that currying is related to, but not the same as partial application.
Yes, they may bring up the same concept, and it's similar. So the shortest description I can think of is like currying is a way of taking a function that may take 3 arguments and converting it to a function that takes 1 argument, and then returns a function that takes 1 argument and returns a function that takes an argument until ultimately there are no more left. Whereas partial application is a way to take a function of n arity and make it a function with less than n arity. So like it's applying 1 function, but it's not necessarily returning back a function that only takes a single argument after that.
So arity is the number of
arguments
to a function.
Yes.
Okay, so currying, it only does 1 at a time?
So currying, it will take an n arity function and turn it into a function that takes 1 arity. It'll take n levels deep. So an n arity function into a 1 arity function n levels deep.
Oh, good. Good way to bring it.
And a partial application takes an n arity function and turns it into a less than n arity function. So it doesn't necessarily return back a function that has just 1.
Oh, wow.
I wish when I was applying for jobs, I could turn in a partial application.
That is such a... I'm really glad you shared that, Jason, because I actually use the second technique, partial application, a lot in my code, and I've always called it currying because I thought that's what it was, and now I realize it's not what it is. Thank you.
So what happens in Elm or other ML type languages is they curry the function for you. That's what the compiler does for you, where you can go and say add a b equals and then a plus b. That by the compiler gets curried into a bunch of single arity functions, whereas partial application is you actually invoking those until you ultimately get the result. So
yeah, words are hard.
Yeah, especially when they're so close.
Yeah.
So in JavaScript, the examples he has in the book, they look kind of weird because you have to put parenthesis, parenthesis, parenthesis to invoke it that many times in a row. But I'm pretty sure in other languages where you don't have to put parentheses around your arguments and they're not comma separated, they're just separated by spaces, it looks a little bit nicer, and you can't really tell the difference between passing in 3 arguments in the first invocation versus invoking it 3 times with 1 argument. Does that make sense?
Yeah.
Is Elm that way, where you don't have parentheses?
You don't have to. There are cases when I have done it, but I think that's because the type of data that I was passing made it so that you needed to separate it. But usually there's no parentheses or anything. It's just like a space, or you can use the pipe command, like the ones we saw earlier in the Elixir examples he had.
Okay.
I think that's another case where if the language has it built in, like currying built in, then it makes it intuitive. But in JavaScript, knowing that you're supposed to call this select query function 4 times is not the most intuitive.
Yeah. It almost seems like a code smell in JavaScript to have to invoke a function that many times.
Yeah.
I know that he was like trying to prove the point though in a familiar language, so
yeah,
it shows what it's doing. But writing code like this is a way to scare people away from your code base.
So if you want to scare people away, use functional programming in a language that's not purely a functional programming language.
Yeah.
Or I guess maybe even in a functional programming language too.
I was going to make a joke and say, if you want to scare people away, use functional programming.
Yeah. So the book mentions this line from Douglas Crockford about monads. where if once you understand them, you lose the ability to explain it to anybody, which I guess you don't really lose the ability if you just now understood it for the first time. But anyway, I hear that all the time. Do either of y'all have the ability to explain monads?
Absolutely not.
So, I mean, a monad is a monoid in the category of endofunctors, right? Which there is.
Oh, I totally get it now.
Yeah.
Thanks.
You're not up to date on your category theory? So there is a guy that does a course on Haskell and category theory called Barthes something or other. I need to go and look up the link on it, but he actually does an explanation on Quora, like, of what that actually means. Because somebody on Quora was like, is this actually true? And he gives the drawn out definition as to like why that actually is, like what the category of an endofunctor is. And I will not try and explain what a monad is within the podcast because it's definitely going to be wrong, and so I won't go there. But I do have some feedback on some of the stuff Rob wrote, actually, with regards to first the select query. He refers to it as, so the select query, I think it's initially written in the hard copy of the book on 305, and he calls the function curried, but if you notice the second function deep within it, it actually takes in 2 arguments. And
True.
So that is not curried. And so I was like, wait a second. And I only figured that out after reading like the currying versus partial application thing. I was like, no, it's got to be 1. Otherwise, it's not currying. So I'll have to submit that in an errata and see.
Yeah, I also feel like there's an errata on page 304 with the dancing with wife function, or the one where he's currying the date night function. And I think at one point the arguments get passed in the wrong order. It's supposed to be who, what, where, but then he passes in dancing wife club. Yeah. So the output actually would have said out with dancing, having fun wife at Club 9.
Nice.
It's like a Mad Lib.
Yeah. Yeah, just put down here.
So anyway, what else about the select query example?
So this is not specific to the select query. I did actually go and rewrite his monad version of it because I didn't like it, and he asked for a new version, so I wrote a gist of it. And mostly I didn't like that he went and wrapped his concatenation of strings within a maybe when it really wasn't necessary. Even he brings that up, that it's not necessary here. He's like, I could just use a template string, but I'm going to go and do this inside of a whole bunch of maybes. And I think that is not right. That is a case of like using a construct that you don't really need. And so like that's the way that you can go and make code bases unapproachable. So don't just go and use it because it looks fun to use. I also don't like his maybe implementation because value winds up just being like a ternary that produces an empty string out of it.
Yeah, I was wondering about that.
Yeah, and so I will have to like send you my gist so you can take a look at that. Not that it's necessarily a whole lot better, but it doesn't do that. It actually gets mad at you if you try and extract a value out of a nothing type maybe. So
okay,
yeah, I guess I went and split it up into 2 classes. One class is called a just, and the other one's called a nothing, resembling that of Haskell, that has those 2 that represent a maybe. You can either be a just with some value in it, or you can be a nothing that has no value. And if you were to try and extract a value out of a nothing, actually Haskell's type system wouldn't even let you do that. But my JavaScript form of it is like, if you're trying to pull a value out of that, then you get an exception thrown at you because you shouldn't be trying to do that.
So for the listener, the maybe is one of his examples of a monad, and it has basically 3 methods on it: is nothing, map, and val. Oh, and also of?
Yeah, of is a static method. So it is a way to take a raw value and convert it into a maybe.
Yeah.
And his functor example of a monkey, first monkey is kind of a weird name for a class. Like, I know it was maybe trying to be nonsensical, but monkey doesn't help get the point across for me, because it kind of makes me think of like when we learned object-oriented programming, and monkey derives from animal, or like monkey extends animal. Also not a good example of OO. So weird choice of name. And secondly, his map implementation on it is wrong. So his map should be returning a new monkey with the result of the function passed to map applied to the value.
Oh, nice.
Because a functor is something that implements map, or fmap in Haskell, that takes in as one argument a function that can transform from a type of A to B, and then it takes a functor that holds an A and returns a functor that holds a B, is the type signature for the thing. And so the important thing with a functor is that whenever you call map on it, you always get a functor back out. You get the same functor back out. It might have a different type that it holds within it, but
right. So it's like when you run map on an array, you still get an array back with possibly different type inside of it.
Exactly. An array is a functor. So it's a way better example that opened my eyes when I first heard it, of like an array is like this container that you can go and you can call map on it, and the function may be called one time, maybe called 0 times. If there's nothing in the list, it could be called 100 times. It doesn't really matter. All you have to care about is that you're going to get an array back from that thing, that if you want, you can go and call map again on it if you want to, over and over and over, because it always returns back a map. Another case that is not truly a functor, but is kind of like one, is like promises in JavaScript, where when you call .then on a promise, then the result of that gives you back a promise. And why it's not truly a functor is because it goes and unwraps. If you return a promise within that then block, like it goes and flattens it out. So that's what makes it not actually a functor.
Oh.
But it's kind of like that. Like if you're not doing the type where you actually go and return a promise within that then block and it's not flattening, then that is functor-esque.
Cool.
Yeah.
Today's episode is brought to you by vSchool. vSchool is Utah's highest ranked coding bootcamp, and they take care of everything for you so you can just focus on learning. And one of the things they take care of is free housing if you need it. And it's just a few blocks from school, located in beautiful downtown Salt Lake City. Or you can learn from the comfort of your own home with vSchool's 100% virtual classroom. And even before classes start, you'll get a career counselor to help you find a job when you graduate. And you'll also get a super transcript. It's like a portfolio, transcript, and letter of recommendation all in one. It'll help an employer quickly understand your strengths and abilities and the work that you've accomplished during your time at vSchool. They encourage you to take a campus tour. You can meet the students, faculty, and even shadow a class to see if it's a good fit for you. If you go visit, tell them that you heard about them on Book Bites podcast, and it will help support the show. vSchool, life awaits. Launch a career in code, design, or data. And thanks to vSchool for sponsoring the show. All right, we should probably move on to the databases chapter.
Yes.
Sure.
So this chapter was not at all what I was expecting it to be. I thought it was going to talk about how to run queries and stuff, but it doesn't. First off, it talks about the forms of a database, which is one thing I remember from college, how to normalize and denormalize data. And then it gets into big data and different types of graphs and sharding and all these things that I wasn't expecting. What'd y'all think?
So starting with the stuff that you do know, what is normalization, Adam?
Let's see. So there's several different forms, but I think the general idea is it's trying to reduce any sort of duplication.
Yeah, reducing duplication, and partly for the sake of disk space when you didn't have a lot of that, and performance and consistency.
Yeah. But it's kind of funny though, because the first normal form example is like a food truck example, and there's only 2 rows of data. So it's not that much data. Oh wait, actually, when he had it in a spreadsheet, it was 2 rows of data. But when he put it into a database in the first normal form, it ended up being 4 different rows and then pieces of data are repeated because Joe Tonks ordered 2 different items. And so Joe's name and email is repeated twice. So breaking that out into separate tables that are relational and point to each other reduces that duplication.
That is interesting that it grows the first time that it moves from the spreadsheet to the database. But that being that you split the embedded list of items out into single rows. So rather than having like items be, I don't know, cheeseburger and hot dog or whatever it was they ordered, instead there's a row for a cheeseburger order and a hot dog order.
Yeah. And of course, in that first form there, the items and the prices are going to get repeated over and over and over every time someone orders that item. But beyond like the forms of normalization that I learned in school, what I thought was super interesting is sometimes in the real world, it's more important to have it be fast, and denormalization is actually okay, and storing calculated fields is okay. So it shows the example of Stack Overflow's database, and there's things in there like count, which can be calculated, but it's faster to just save it there. And you can kind of just update those things like on a regular basis and store them in the database.
Makes sense. In specific cases, like, and you trade potential consistency problems for performance, like that can sometimes be a fair trade-off. And I could certainly see that with Stack Overflow's counts on things, because if every time they needed to load up the page to show how many people have viewed an answer or given a thumbs up to an answer, I've seen it in the past before working on systems where there's a rating system in there where people can go and like leave reviews rather than going and calculating like how many out of 5 stars it is every time somebody loads the page based on the list of reviews. Just holding that count can make it significantly faster to load, because that can be a lot of stars to load, especially if you're loading like a page listing, 20 items on it and showing their rankings. Like that could be really heavyweight compared to just memoizing it or caching it somewhere.
Yeah, and the more normalized it is, the more tables you have to merge together, and that can take a lot of processing. So I should mention the third normal form, which is the most normalized form. It says non-keys describe the key and nothing else. So each table needs to have a key that's usually an ID or something, and then everything else in there only describes that one item, and there's nothing extra. If there's something extra, it should be in a different table.
I did do some digging and found that third normal form is not the most normal form.
Oh.
Yeah. I found up to fifth normal form. So, yeah. And I mean, fifth normal form kind of makes fourth obsolete. It replaces the concepts in fourth. But for a good example, if you look at Wikipedia's fourth normal form, they go and describe it. But in short, if you have a situation where, say you have a table with 3 columns in it, X, Y, and Z, if X and Y are always the same for any Z, then that is a redundant case that you can go and break out to its own table. Wikipedia gives like an example of a pizza place that the same facility serves different counties, but always serves the same type of pizza in any of those counties. And so it's redundant for that to be the case. So like it's a less common thing for you to even run into with third normal form, but it's possible. And then fifth normal form takes that from being an n of 2 where X and Y were always the same. And fifth normal form says that it applies to n number of columns. So any number of columns that winds up happening for. And that one took a little bit more staring at of like, why is this here? But apparently they're way out there cases. Like if you're in fourth normal form, you're probably in fifth normal form unless you have a really particular database structure. But ideally, like third normal form will get you a long ways, and fourth is more about cutting out redundancy more than anything.
So I love that the Wikipedia article on fifth normal form uses an example of traveling salesman.
Mm-hmm.
because that's just a traveling salesman is a super hard problem, and then figuring out what this means also seems like a super hard problem.
Hard problem inception.
Yep.
The thing that I grokked from like the salesman idea was like, if you have a salesman that sells GM and GM produces trucks and GM produces cars, then that salesman also needs to sell cars or something. That's the kind of case that it's there to handle. If someone's representing some other company and that company sells this thing, therefore that person should sell this thing. I don't know like a real world case.
Yeah. It's just really weird because you end up with a table called product types by brand. And that just doesn't seem like a very useful table name.
And yet another join to throw into your pile of joins. So that's why like third normal form feels like a pretty happy medium for me. Like it's the way that I would generally structure my databases, where everything's got a primary key and references across that. There's possibility, or surely like I have redundancies in there, but storing that a few extra times, probably not that big of a deal.
Yeah, because he mentions in the book that a lot of developers will overestimate how big their database is going to be. And really, it's probably not going to be very big unless you're Ancestry.com or something.
So, Safia, you said that you spent a lot of time in this chapter and enjoyed it. Tell me what you found.
I really liked, not necessarily the first half of the chapter on normalizations, but I really liked the part on distributed database systems and onward. And basically what this section was talking about was the fact that, you know, maybe databases were invented in like the 70s, 80s, but in more recent times, you have the emergence of faster computers with more CPU and just like more accessible hardware. So one thing you can do now is, instead of just having your database on one computer and always pinging that, you can now have your database distributed across multiple computers because that hardware is so cheap. And that comes in with its own set of challenges around how you ensure that things are atomic and consistent, and that your database is always available to respond to requests from your product and stuff like that. And it discussed a couple of like, you know, what does this adjective mean type things. One of them is ACID, which is standing for atomic, consistent, isolated, and durable. And it's sort of a way of discussing some of the guarantees that a database might give you. So for example, saying that it's atomic means that a single transaction is going to happen, or it's not. There's no such thing as making a partial change to the data in your database.
It's the Yoda principle, right? Do or do not. There is no try.
Oh. You're coming in strong with the puns today.
Yeah, nailing it.
I threw you off, didn't I?
You did, because I was like, wait, what does he mean, the Yoda? And then I was like, oh, I see. So, and then there's other principles like consistency, which is ensuring that your database will change completely, not partially. And when I like first learned about these principles, I was really confused about what the difference was between something being atomic and something being consistent, because it sounded like people were saying the same thing but using different words. But what I learned is that atomic is referring to the literal data that gets manipulated in your database. So like a transaction that adds a new row of data. Consistency is more talking about, I guess you could say, some of like the integrity or data rules that you might have in your database. So for example, like a transaction that would be atomic but not consistent is one where you add a new row of data to your database, but that new row contains a unique field that collides with an existing row of data. So it validates like the logical requirements of your database. So I was like confused about that for a while, and that's one thing that I sometimes need to remind myself what the distinction is.
Yeah, I think the example I was thinking of, I don't know if this is correct or not, but maybe you have some duplicated data in your database because it's not completely normalized, right? And so if you change or write some data, but you don't do it in both places, that might be an inconsistency.
I don't know about that. Jason, do you have any thoughts on it?
So the way that I kind of understand it is that with consistency, you're not ever in a partial state. So as you talked about inserting a row, for sure, like that row is either entirely in or entirely not in, regardless of a transaction state. And that that database is, when it terms consistency, that means across the board. So like if that database happens to scale even multiple machines, they know the state between them is the same. So you're not in a case where one database has a certain value in it and then another database has a different value in it. Like if you have a replicated database, consistency would say like the master matches one of its slaves machines. That's for sure in a consistent setup. The cap theorem was one that was brought up for me in school. I remember them talking about it, where you can choose two out of the cap theorem of the consistency, availability, and partition tolerance. And it kind of dismisses that a little bit later in the book, like immediately after that. So what did you take for availability out of that, Safia?
What do you mean by that?
I guess you had talked about your interpretation, or like how you read into consistency and how that varies versus atomic. And I know you were going through the cap theorem, so availability, what do you understand that as?
So the way I thought about it, given the context of what he explained in the book, is that this might be a very simple way to think about it, but any node that you send a request to, a node being some sort of machine that holds your data, is going to return a response to a request for a query.
Gotcha.
Yeah.
Yeah. Available for response.
Yeah.
Yeah.
Yeah, I didn't totally understand the third one, though, which is partition tolerance.
So I guess it's related to availability in my mind, in the sense that if you have nodes that are failing, your system is still going to be able to respond, and also respond with data that is like reasonably consistent.
Yeah, that's one of those cases where there are some databases that lean towards the AP part of the cap theorem being both available and partition tolerant. So what that might mean is like if you have 5 computers, there's 5 servers in your cluster, and like 2 of them get separated, whether they go down, or worst case, you get the split brain effect where they're not actually down, they just can't see each other over the network. Then what will happen is they will continue to serve requests, and then the goal is that eventually they'll see each other once again and come back to an eventually consistent state. But like during that interim when they're down, they can still field the request and hopefully have a resolution pattern in place. And that's where distributed computing gets really hard and promises that some databases don't necessarily always hold up. There is a blog post series, I think it was called Call Me Maybe, and it's about a project called Jepsen, and his name is like a fire on APHYR on Twitter. It's Kyle something.
Oh yeah.
And interesting character to follow on Twitter, but he is pretty brilliant when it comes to going and putting databases to the test, where like he'll go and make a set of virtual machines that are all running a database, and then he'll go and like split brain them and fire a whole bunch of requests and see what the databases do, and then can they like consolidate those requests back together, or like do requests that were sent get lost. And he goes and he puts a whole bunch of different databases through the ringer to see actually what happens when they have that happen, because partition tolerance is definitely like the hardest thing, I would say, because consistency being easy in terms of like if something's down, you can just stop the world and say I'm not going to be available at all.
Yeah.
And so like, yeah, I am consistent and partition tolerant by saying I don't accept requests unless everybody is alive and talking to me. But yeah, the other ones though are definitely trickier, and so it's a good read. I will get a link to his blog post because they're a good series.
Cool. Yeah, as I was reading the section, it's talking about eventual consistency and how Rethink DB does this as an example of a distributed database. And I was wearing my Rethink DB shirt as I was reading that, actually. I was like, oh.
Ooh, repping.
Yeah. And, it mentions that Rethink DB shut its doors as a company, but it's still an open source and will continue on. So that's pretty cool. I don't know. Have either of you used a distributed database before?
I've used MongoDB.
Okay.
But not Rethink. And
okay.
Went through the process of actually migrating Mongo over to a Postgres database. And in the process found some consistency flaws in it. So that made you in part of the way that we built the application around it and not understanding the trade-offs that we were making on that front. But yeah, I've used Mongo, and Rethink seems, in my mind, I've always looked at it as like a better Mongo, but yeah, I haven't spent enough time to be totally positive on that front.
Yeah, I don't know if Firebase, or as is now known, Firebase Firestore, is in this camp of distributed databases or not. Do you know?
I don't know what guarantees they provide.
Okay. It does seem similar to this if it's not.
I know they do something to scale out wide, but I'm not sure, so I can't speak to it. I've never heard the alternative to ACID, that base that was mentioned in there. That was new to me.
Yeah, I have not heard of it either.
Basically available, soft state, and eventually consistent.
Oh, okay.
I've heard of the term eventually consistent, but I haven't heard of basically available and then soft state, and then kind of all three of those being clumped into one concept.
Yeah, it's confusing because it's base has 3 letters, but
yes.
It's really only 3 things.
Yeah.
Basically available, soft state, and eventually consistent.
Yeah, eventually consistent is the term most familiar for me. It was something that I learned a bit about when looking at event sourcing as a way of storing things.
I just now got it. Acid and base.
Oh, boo.
I didn't understand
my
that they're like opposites.
Wait, no, I just got it too. This is... we need to... No! Oh my gosh, Adam.
They must have tried so hard to make that base.
Oh my gosh. Okay. Wow. Honestly, hats off. That's pretty impressive.
Yeah. That was too cunning.
Jason, did you get it just now too, or did you?
Oh, I got it just now. Yeah. I didn't even pick it up. So
we're here just unraveling all of the puns in computing.
Yes, it's so full of clever namings that are puns and acronyms within acronyms. I don't really have anything else in this chapter. But I did think the part was cool that said how much data different companies collect and store. So the NSA collects 29 petabytes per day, but Google collects 100 and Facebook collects 600. I don't know how Facebook is collecting more than Google. That's crazy.
I can see it, kind of.
It's like Google is collecting the entire internet, and then Facebook is collecting people.
But I mean, Facebook is also, in some regard, collecting the entire internet from a different side. Like, because people interaction is huge, and then there's Facebook trackers on everything, because everybody's got the share it button. So I can see it.
Yep. But then Google's storing the most amount of data, 15,000 petabytes. And I thought it was cool too to like put these numbers in perspective by thinking about how many years that would be if it was seconds instead of bytes.
Huh, I hadn't considered that.
1 million seconds is almost 12 days. 1 billion seconds is just over 31 years. And then 1 trillion seconds jumps to 317 centuries.
Jeez.
It's crazy.
And those are true big data problems.
Yeah.
That is one thing that he does talk about, and we mentioned before, is like overestimating the amount of data that's in our systems is easy to do. A lot of times you can hold it in memory, and you don't need like Hadoop to go and process your gigabyte of data or however much you have. And you can load that readily and run it with like a Python script and probably get your answer a lot faster.
Okay, so I wasn't completely understanding when I was reading the book, but now I think I get it. So if your data is bigger than the amount of RAM that you have, when it's running a query, it can't hold all that data in memory. So that's
Right.
That's the problem.
Yeah. So then you wind up having to like page onto disk, like put memory onto disk to pull new stuff out to your RAM again in order to do it. And it just becomes a lot slower. Like perf just dives. Like as soon as you start using disk instead of RAM. So yeah, you just like if your data passes RAM size, then yeah, you're going to run into performance problems. And that's when you need sharding and replication.
But that's pretty advanced database stuff right there if you need to do sharding.
Yep. And the big takeaway from it is if you're going to do that, just let your database pick the key on how it separates out data, and don't try and be too smart and pick out ways that you want to separate it, because you may likely get it wrong.
Yeah. All right. Well, anything else on this?
Not at the moment.
That's all I've got.
Cool. Well, thanks so much for listening. If you want to support the show, please rate us in iTunes and follow us on Twitter and say hi on Twitter. We'd really appreciate that. Our Twitter account is at BookBitesFM. I am at Agar Har. Jason is at Staten Jason, and Safia is at Captain Safia. As always, you can find the show notes and transcript for the episode at orbit.fm/bookbites/17. See you next time.
Bye, everyone.
Bye.
Bye.